Hello students, today I'm going to discuss 4.9, which is antiderivatives. This lesson is very important and you need to learn it really well because antiderivatives and integrals are very important and you're going to use them from now on in your calculus sequence and in other lessons or courses as well. Okay, so a function f is an antiderivative of an f, lower letter, on an interval I, provided f prime of x equals f of x. Okay, so what does that mean? If, for example, we have f of x equals 1, a function, what is the antiderivative of f? So what is that f of x? What function, when you differentiate, is 1? Well, let's think about it. What function prime is 1? Well, actually, it's x. But let's think a little bit. What if I say, so if I check it, check, x prime is 1. Okay, but I want you to check for me x plus 1 prime. What is that? Well, that's 1 as well. How about x plus 2 prime? Well, that's 1 as well. How about x minus 3 prime? That's 1 as well. So what does that mean? It means f of x is x plus c, where c is a constant. So find the antiderivative of f, we found it. The antiderivative of 1, it's x plus c, because x plus a constant prime gives us 1. How about the second one? Let f of x equals x. Find f of x. So again, the question is, what function differentiated is x? Well, if you think about it, x squared, right? When you differentiate x squared, so x squared prime is 2x, right? So then, in order for me to get x, I will have to divide by 2. So x squared over 2 prime, so now x squared over 2 prime is 1 over 2 comes in front and then 2x, which gives us x. But I have to add the constant because you saw the constant prime is 0, so it always gonna give me an answer. So basically, if you look at it, these answers that we are getting, the ones that I'm highlighting, right? Let me erase this one. The ones that I highlighted, all of them have plus a constant. So our answer is not just a function, it's a family of functions, because c generates, with the different values of c, we generate a different function. Okay, so let's look at this problem. F of x equals 3x squared. Find the antiderivative. So I want to find f of x so that when you differentiate that, you get 3x squared. Well, think about it. What function prime is 3x squared? That's correct, x to the third. But we have to add the c, it's a constant. So let's check. X to the third plus c prime is 3x squared plus 0, right? So that's it. We found that the antiderivative of f of x is x cubed plus c. And here you have a bunch of formulas, a set of formulas that you have to memorize. The notation for antiderivative, it's this integral. And this sign, it's pretty much like an elongated S, because we're going to see in chapter 5 that these integrals are actually sums. So please read every single formula and learn it. So first one, it's what? Well, it was the power rule if we read it from left to right, right? The derivative of x to p, so x p prime, it's px to p minus 1. Well, if I differentiate, if I want to get just p, not p minus 1, I have to have one extra p. So integral of x to the p dx is x to p plus 1 over p plus 1 plus c. So far, we'll just look at the notations, we have this symbol and we have the dx, which we are going to talk about it in chapter 5, what's the actual meaning of this dx. And so integral, if you have to calculate, for example, integral of x to the 4th dx, right? If you want to find what function prime gives you x to the 4th, what you have to do is say p equals 4 and replace it in the first formula, x to the 4 plus 1 over 4 plus 1 plus the c, so it's x to the 5th over 5 plus c. And we did an example. The second formula says that if you have to calculate an integral, so the second formula, if you have to calculate an integral of a constant times a function, the constant comes in front. The third formula says if you have to calculate the integral of a sum of two functions, you can just distribute the integral to each function. The fourth one says integral of cosine of ax. So let's think about it. What function prime its cosine? That's true, it's sine. Only in this case, there is a constant in front of x, right? So there is this a. So that comes in front. So if you have cosine of ax, then you get 1 over a sine of ax. And so on. Read them carefully. Integral of sine of ax is negative 1 over a cosine of ax plus c. Integral of secant square, well, what function prime is secant square? Tangent, but we still have to have this ax 1 over a in front, and so on the other two formulas. So let's take a look at some examples. So first one says compute integral of 3x to the 5th minus 5x to the 9th dx. So the very first thing, distribute the integral and the dx to each term. So here you go, we have two integrals. Then the formula says if you have constants, put those in front. Integral of x to the 5th dx minus 5 integral of x to the 9 dx. So basically our problem is using the first formula. So x to the 6 over 6 because of these 5, so 1 extra, minus 5x to the 10 over 10 plus c. I'm going to simplify a bit, so I get x to the 6 over 2 minus x to the 10 over 2 plus c, and we calculated our first problem. Okay, if we take a look at the second one, well, I have three terms, 3x to the 4th, 2, and negative 3x to the 2nd. So I'm going to have three integrals. Integral of 3 over x to the 4th dx plus integral of 2 dx minus integral of 3 over x squared dx. Each time the integral sign and so on. The constant comes in front, so I have 3 times. In the formula list here, 5, 6, 7, 8, 9, I don't have any that have powers at the bottom, but I can write x to negative 4, integral of x to negative 4 dx, plus 2 integral of, well, what is left if I move the 2 out? It's a dx, minus 3 integral of x to negative 2 dx. So I just transform them into powers so that I can use the first formula. So 3 times x to negative 4 plus 1 over negative 4 plus 1, plus 2 times, well, here, if there is nothing, I can put a 1. So what's the integral of 1? Integral of 1, let me write that, integral of 1 dx. What function prime is 1? X, right? We talked about it at the beginning. So it's 2x minus 3 times x to negative 2 plus 1 over negative 2 plus 1. We'll put the plus c at the end. So 3 times x to negative 3 over negative 3 plus 2x minus 3 times x to negative 1 over negative 1. I'm going to arrange it a bit, 3 and negative 3, so it's negative 1 over x to the 3rd plus 2x plus 3 over x plus c. And this would be the final answer. How many solutions we got? We got the family of solutions. We have infinitely many for any c constant. So if I put c equals 1, I have one function. If I put c equals 3, I have another function, and so on. Example 3. Well, again, I'm going to write fifth root of r to the second dr as a rational exponent. So r to 2 over 5 dr. So copy the base and 2 over 5 plus 1 over 2 over 5 plus 1. So if we add, we get 7 over 5 and then times 5 over 7 because that's the denominator, it's 7 over 5, so the reciprocal of that plus c. But the original problem was with radicals, so I'm going to write my answer with radicals. So 5 over 7 fifth root of r to the 7 plus c. And I can actually simplify, if you remember the algebra, it's r square fifth root of r to the second plus c. This is the final answer. So all these three problems actually used the very first formula. Okay, how about 4? Well, again, I'm going to distribute, so integral of sine of 2y dy plus integral of cosine of 3y dy. So the variable is the same with the d, so we are okay. Now, integral of sine of ax dx, if you look at the formulas, integral of sine, which one is it? It's 5, right? Let me highlight it in purple. Oh, okay. So purple with yellow is red. Interesting, right? So integral of sine of ax is negative 1 over a cosine of ax. So in our case is negative 1 over a cosine of ax. So in our case, a is 2. Let me make a red one. Nice. So we have negative 1 over 2 cosine of 2y and integral of cosine of 3. Let's write the formula. Cosine of ax dx. It's 1 over a sine of ax. Well, plus the c, but the c comes in later. So plus 1 over 3 sine of 3y dy. And this is the answer of example 4. For example 5, which formula works for example 5? Well, we had the secant and tangent, so it's 1 over a secant of ax. So we have 1 over 4 secant of 4y plus c. That's it. It was just the formula. Okay, and I'm going to pause here. Please try to do these problems on your own and check then my solutions. Okay, bye.